I want to consider one more problem, and it is this antiderivative from -2 to 4, or the integral of 3x dx. So as I mentioned, that should be the region trapped between the function and the x-axis, so that region would have to be over here, and then also here. Notice where I'm pinching. I'm pinching between the function and the x-axis, okay? And then I also have to have my region trapped between x equals -2 and 4, so it has to be in here. So that's why it is this region, okay? You should note that part of the region is below the x-axis. The other part of the region is above the x-axis, okay? Now, if I were to use the fundamental theorem of calculus, and this is directly from your notes, so please print them so that you can follow along. I did this the long way. I found the antiderivative right there. Notice labeled as capital F. I plugged the bigger number in and subtracted off what happened for my antiderivative at the smaller number, and I found out that there were 18 units of area. Now, I have to be really careful because this is an interesting problem, considering that some of the region's below and some of it's above. So if I were to do this on the calculator, I want to show you that I didn't have to use the fundamental theorem of calculus, and please don't do it by hand unless it says use the fundamental theorem of calculus. So if I decided to let the calculator do all the work, you always put in the original function. Don't take the antiderivative. I cannot emphasize that enough. Let the calculator do the work for you. So y equals 3x, you graph that, and now you're going to do second calc, number 7. And your lower limit was -2, the upper limit is 4. Right, so you can see that the calculator put in an infinite number of rectangles for the region trapped between the x-axis and the function, starting at x equals -2, ending at 4. And notice the calculator also got 18, right? Let me zoom in so that you can see that. There you go. All right. So on the very next page of your notes, you should notice that I decided to break up the region below the x-axis with the region above the x-axis. So here is that left piece, right? This is the piece that was on the left. And here's the piece that was on the right. Hold on, give me a minute so I can show it to you. Okay, so there were two pieces, one below the x-axis, the other above the x-axis. Now I want to show you what my calculator does. So I'm going to clear out my original function, and I'll start over again so that you can see it. So y equals 3x, graph that. Okay, I'm only going to do the piece that's on the left, and I can see that it hits at 0. If you'd like to do second calc number 2 and find that x-intercept, then you certainly can. So second calc, okay, you'll notice that when I do that, when I break it up in that way, then I start at -2 and I end at x equals 0. Okay, I'll say that again. I start at x equals -2 and end at 0. This one is going to pick up at x equals 0 and it'll go to x equals 4. So I'm separated into two pieces. All right, so second calc number 7. Let me do the piece on the left. Lower limit -2, upper limit is 0. Oops, I'm sorry. I didn't realize that I hadn't graphed it. So second calc, number 7, lower limit -2, upper limit is 0. Okay, so look at what my calculator gives me. I'm going to zoom in so that you can see it. My calculator says that's -6. Now the reason that that's the case is that when you find an antiderivative, it's directional. It'll say, hey, wait a minute, you're below the x-axis. Your region is below the x-axis, so it'll give you a negative number. Now, if my region is above the x-axis, it should give me a positive number. Again, if your region is below the x-axis, you should get a negative antiderivative. It should spit out a negative. Okay, so let me start over again so that you can see what happens for the other region. Okay, so y equals 3x. Let me graph that. And now I'm going to do this one, right, where I go from 0 to 4. Okay, so second calc number 7, x equals 0 to x equals 4. And notice it gives me positive 24. So let me zoom out from that because we need to consider what's occurring. So think about this. For this piece that's on the left, we got -6 because the region was below the x-axis. For the piece that's on the right, we got +24 because the region was completely above the x-axis. But if you remember, when we did this on the calculator and we did it all together, we got that our antiderivative is +18, right? I just showed that to you on the calculator, right? Our calculator found that when we find this antiderivative and we start from -2, we start all the way over here and we get to 4, we should get +18. Now the reason for that is because your calculator takes into account, yeah, it'll say you got 24 positive units here. Positive in the sense that it's above the x-axis, but you also have 16 units, I'm sorry, not 16, but 6 units below the x-axis. So the calculator is going to look at the cumulative amount of area. So what do I mean by that? The calculator is going to say you have 18 more units above the x-axis than below it. This is what your calculator is doing, right? Your calculator is acknowledging you've got 6 units below the x-axis, but you've got 24 above it. So in total, you have 18 more units above the x-axis than below it. So this number is not just 18 units of area, but it's specifically 18 more units of area above the x-axis than below it. All right, hold a second. I'll zoom in so that you can see that. That's what that means. Okay, it tries to look at the big picture. You got some below, some above. In total, you have more above than below it. So please keep that in mind. Every time you do an antiderivative, it is directional. Okay, so for the last page of that note, I just want to summarize what I said earlier. Here's the 4 criteria. Every time you find an antiderivative, you are finding the region trapped between whatever this function is. The x-axis, you should start at A and end at B. Make sure you're doing your 2 pinches. There's one pinch between the function and the x-axis. Here's the second pinch between x equals A and x equals B. That is your shaded region. Your calculator should show you. Okay, here's the last thing that I wanted to point out. Sometimes your antiderivative is positive and sometimes it's negative. You should get positive antiderivative if your region is above the x-axis, negative if your region is below the x-axis. Okay, so please keep those things in mind going forward.